Hello everyone and welcome to the channel. In today's video, we will cover a very interesting and cool technique in deep learning, and we will build an image recognition model that can be used in real-life use cases. This cool technique is called transfer learning, and in a nutshell, transfer learning is the process of reusing a pre-built, pre-trained neural network. Those neural networks usually have been tuned and trained on very large data sets. And that's really amazing because we all know how challenging it can be to create a dataset large enough to train your CNN to achieve accurate outputs. And transfer learning takes care of that. So, in this video, rather than building a CNN from scratch, we will use a well-known neural network called VGG16. This neural network is built in keras, and it achieves 92.7% rank 5 test accuracy in ImageNet. And for those who don't know, ImageNet is a huge data set of more than 14 million images belonging to 22,000 categories. A fun fact also, this model is named VGG16 because it was created by the Visual Geometry group from Oxford, and it has 16 layers depth, hence the name VGG16. So let's get right into it.
Okay, so in this example, I'm going to be using the Colab platform. Feel free to use any other platform that you feel comfortable with. So straightforward, we're going to come here to the file and create a new notebook. Okay. And the first thing we're going to do is to start importing the libraries that we are going to use in this example. So the first library we're going to import is the keras. So import keras. I'm going to run this one first I'm going to run this one first so that I can get the prediction in later statements. So next we're gonna call the image data generator. So I think from keras import from keras dot pre-processing dot image import image data generator. Next we're gonna call the sequential library dot models import sequential next so from keras dot layers. So basically we're importing everything that we need to call this excuse me, to call the VGG16 model. So dot layers import for dense, right, and from keras dot applications import VGG16, and from keras dot applications dot VGG So as you can see here, we have many other built-in models in the keras library, like the Inception, ResNet, Inception, MobileNet. This is out of scope for this video, but we will cover them in later videos. So VGG16, import processing, I guess. Yeah, pre-process input. Pre-process input so that it will accept the images in the proper size. So we don't need to kind of manipulate the images. It's gonna just resize the images and accept them in the format that we give it. Okay, so that's it. We have imported the libraries that we need. Next, we're gonna import the training images, and for this exercise, we're gonna use we're gonna download the images with cracks. Some of them with cracks in the concrete, some of them were without cracks, and we're gonna use the wget. Okay. All right. And let's run this one first. Okay. And now we're downloading the zip file of the images. Okay, so now we have the concrete data underscore week4 .zip. Next, we're going to unzip this file. So unzip, and we're going to take this file name. All right. So while this is unzipping, so what we're gonna do basically is we're gonna use the VGG16 model to classify images. It's gonna be a binary classifier, so it's gonna tell us whether the concrete image or the image of the concrete has cracks in it or not. So it's binary. So there are gonna be two classes in this classifier. One thing to note about the VGG16, it accepts images with size 224 by 224. So, okay. Next, we're gonna define the number of classes as a variable. I'm gonna call it number of classes equals 2. And the image size equals 224. And we're gonna send those images in batches of 100 images per batch. So we're gonna define the batches. This is gonna be necessary in the image data generator parameters. So batch size for training equals 100, and batch size for training, for validation, and it's going to be 100 as well. And next we're going to create a new cell. And in this cell, we're going to define the image data generator. So let's call it data generator equals image data generator, and we're gonna pass in the pre-processing function, the function that we have defined here, this one here, okay, so that it knows what type or what size of images to pass to the VGG16. Okay, so pre-processing function. So it will pre-process the images as per the requirements of the VGG16. So equals pre-process inputs, pre-process inputs. Okay. Right. Next. Well, the next we're gonna define the way that the images are gonna flow from the directory in which the images are saved, and we're gonna use the data generator to do that. So we're gonna define a data generator here. We're gonna call it. We're gonna need one for training and one for validation. So we're gonna call the training one train validation, or sorry, train generator equals data generator okay, data generator dot flow from directory. Okay, let's run those cells. All right, so dot flow from directory, and we're gonna give it the directory in which the images of for training are. So it's gonna be first. Okay, so here. Okay, concrete data, it's concrete data week 4 / train. I guess we can know exactly where those are. Okay, so here's the folder. Okay, so it has the train and the validation, and it has also images for testing for later on. Okay, so here's the training images. Next is the target size, target size, right? So the target size equals the it's an X by Y type of dimension for the image. So we already defined the variable for the size, which is 224. So what we're gonna do here, we're gonna say image size by image size. Yeah. Okay. Next is the batch size. Batch size equals the batch size for training. Okay. And finally, the class mode. Class mode equals Well, it's going to be categorical. Okay, let's run this. Okay, so it says here that it found 30,000 images belonging to 2 classes. Okay. All right. So now what we're going to do next, we're going to define, since we're defining the data generators, we're going to define the one for the validation as well. And I'm simply just going to copy and paste this one here. I'm going to rename it to validation. Okay, and I'm going to change the path here. I think the rest is the same. Yeah, so it's going to be validation. All right. Okay, so next we're going to start defining the model. Okay, so we're going to define a variable called model, and it's equal to sequential I think it's sequential. Yeah. All right. And now we go into the interesting part, the actual transfer learning part. So let's run this one first. Next, we're gonna add the VGG16 to our model. So what we have done here is we defined the model, and then we're gonna add the VGG16 to our model. Okay, so here we're gonna say model dot add. VGG16, and the parameters for the VGG16 is include top, I guess, equals false, and we're gonna use average pooling. So pooling pooling equals VG, and the weights, it's gonna be ImageNet. Okay, ImageNet. Okay, and I guess that's about it. Yeah, that's it. Oops. Yeah, it's VGG16. And okay, right. 16. Yep. Oh, yeah. Sorry for this mistake, guys. So yeah, it was just the definition of the model here. It's case sensitive for some reason. But anyway, now it should be running. Yeah. So now it's running. Okay. All right, good. So next we're gonna add a layer, a softmax layer, since this is a classification model, so it's gonna be a softmax. So we're gonna say model dot layers model dot add, and we're gonna add a dense layer. Okay, and it's gonna have the number of classes, which we already have defined as a variable, so it's called number of classes. And the activation is going to be softmax, as we said, because this is a classification. All right, now let's see how many layers we have in this model overall. We can know that by simply typing model dot layers. Okay. Core.dense. Okay, let's try something else. Model dot layers. Can see 0. Okay. Dot layers. Okay. So those are the layers in this model. Okay, you can see here an input layer, convolution, max pooling, convolution, max pooling, so on and so forth. Okay. Now, what we're gonna do next is we're gonna start training this model. Now, warning here. I think I need to mention this. It's very important to know that the VGG16 requires a lot of time for training. It consumes a lot of time, and I don't have that much of GPUs on my account here, and I think it's gonna take north of an 8 hours or something. So when I start training the model, I'm just gonna pause, and then we're gonna come back when it's finished. Okay, so we train it as such. So we say model dot layers dot trainable zero dot trainable okay dot trainable equals false, because we don't want to retrain the entire model. Okay, it's already trained on the ImageNet dataset, as we mentioned in the beginning of this video, which is a huge dataset, and we just don't want to retrain it. So or to retrain the layers that form the algorithm that forms this model. Okay. What we're simply doing is we're taking a pre-trained model, as we said, and then we're gonna train the input and the output layers on our images, and that's it. Okay. Model dot compile optimizer equals And we're going to use the Atom optimizer, of course. The loss function is going to be categorical cross entropy. Categorical cross entropy. I hope I'm okay. So it's correct. Okay, categorical cross entropy. Yeah. And we're going to define the metrics, and the metrics is going to be accuracy. Accuracy. Yeah. Okay. Next, we're gonna define the steps per epoch. Steps per epoch. For training, it's gonna be the length of the training generator. Okay, so for the steps per epoch are gonna be the length of the training generator. Okay. And for the training as well. Yeah, we're gonna set it for training as well. Steps per epoch. For the validation. Here it's gonna be for training, and this is going to be for validation of the validation generator. Okay, and the number of epochs, we're going to set it to 2 epochs. That's more than enough. Okay. What? Categorical. Okay. Now we're gonna start fitting the model. We're gonna say fitting history equals to model.fit. Okay. Sorry, model.fit generator. Yeah, since we're using an image data generator. Okay. We're gonna give it the training generator, and the steps per epoch are going to be steps for training. Okay. And the epochs equals number of epochs, and next is the verbose. Okay, verbose equals 1, and we're going to give it the validation so that it can validate while fitting. Okay, so the validation data is going to be validation generator, and validation steps equals the steps for validation. And yeah, that's it, I guess. Let's see. Training generator. Okay, for training. Steps per epoch. Okay, epochs. Propose. The validation data. And the validation steps. That's it. Okay. Now let the waiting begin, because it's going to take a lot of time. So I guess I'm gonna go to sleep. When I wake up, maybe it's going to be finished, and then we're gonna continue from there.
All right, so here we go again. The model has finished fitting. I believe it took like 9 hours, and as you can see here, the results look amazing. The accuracy on both the training and the validation is high. So in the first epoch, we can see here that the accuracy was 96, almost 96%, and the validation was 99. But in the second epoch, it was 99 in the validation and the training and the validation. So the next thing we must do after we train such models is to save that model. So personally, I like to run these 2 lines of code. This will connect your notebook to your Google Drive, and then in the next line here, in the next cell, you can see that I'm saving the model in my drive so that we can load it later on. Now, what happened here is that after the model finished running and finished the fitting, the notebook got disconnected. So thank God I already have been through this before, and I have a copy of the model saved, which we're gonna use to continue this exercise. Okay, so here we go. So we saved the model here. Okay, and next is to start the testing. Okay, so now we will see how we can load the model. Let me show you here the content in my content folder under my drive. Okay, saved. So it's saved here. Okay, so let's copy the path, and we can load the model. Well, first we have to import the load model from keras.models. So we say from keras.models import load model. All right. And next we will say VGG16 saved equals, and say load model. Okay, right. Then we'll just paste the path here. Okay. And let's see. That's okay. So the model is saved basically, and we're gonna see that now. So next, let's start testing it. And to test the model, it's the same as the fitting somewhat. We will create a data generator, and we're gonna load or flow all the testing images in batches to the trained model in order for us to verify and validate the results, the testing results. Okay, so say test generator equals data generator dot flow. Oh, okay. So again, test generator equals data generator dot flow from directory. And we'll say here concrete data week 4 slash tests. Next is the target size equals image size by image size. We're going to turn off the shuffle. Oops, and that's it. I actually turned off the shuffle because when I turned it on, I got an error. So while I was messing around with the parameters for the testing, I found after some research that the shuffle fixes that problem, and it just guesses the or processes the pictures in the same order that they are, which is shuffled. They're not like ordered in some way. But anyhow, so let's continue. Steps per epoch for testing equals the length of test test generator. Okay. So let's run this one here. Okay, so it found 500 images belonging to 2 classes. All right, great. So far, so good. Now the next thing is to test it actually. So let's say test history equals model dot evaluate. Okay, model dot. Oh. So this is the model now. Dot evaluate generator. Okay. Test generator. Steps per epoch for testing. And the verbose equals 1. Okay, so let's also display the let's print the accuracy after we finish. So let's go ahead and print, let's say accuracy for testing is and we'll say test history. One. All right. Okay, so again, I'm gonna pause here, and we'll come back when this is finished. Okay, guys. So now the evaluation has completed, and the accuracy, as we can see here, is 99.5%, which is very impressive. Now, next thing is we want to start predicting. So what we will do, we will load the images to be for this model, and the model is going to go through all the images at once, and then start making the prediction. And in order to do that, we're going to use the predict generator. And after that, we're going to see how the predictions look like. Basically, what the output of this is that there's going to be an array, okay, and with possibilities from 0 to 1 for each image. So if the possibility, if the negative was higher, then it's going to be a no crack in concrete, and if the possibility for the positive was more than the negative, then it's going to be a picture with a crack in it in the concrete. So let's put that into action now. We'll say predict equals our model here dot predict generator, and we're going to give it the testing images, the same as the evaluation. Test gen, that's right, and steps will equal to steps per epoch test, and verbose equals 1. Okay, so let's run this one here. So basically what we will do, how we can check the predictions, we can go through any of the pictures here as such. So if you want to go to the first image, that would be 0. And since it's a binary classification, so we'll take the first. So for the first image, we'll take the first, the percentage for prediction for the first class, and we'll see it. And then we can say same here for the first image, give me the second prediction possibility. So this is the, so basically this is the first possibility for the first image, and this is the second possibility for the first image, the first class, and the possibility for the first class and the possibility for the second class. Okay, this is how it's going to be. So what we can do, we can simply create a for loop and just get all the predictions at once. So what we can do is we'll say for I in, let's say, range from 0 to the length of the prediction or the prediction array. We'll say the negative is the first one, and the positive is the second one. Okay, and we can add also if the possibility for the negative was higher than the positive, then print negative, for example. If negative was more than positive, then print negative. Else print positive. And that's it. We will just wait for a minute for the prediction to complete, and we will be right back. Okay, back at it again. The prediction has completed. So before we run this, let's see how many predictions were made. So it made 500 predictions. We can go through those predictions. Yeah, you can see that there are negative and there are positive. And that's it, guys. We can also load any image that we want into this model, and it's going to predict it easily. So that's it for this episode, or for this video, and we'll catch you guys in the next one. Take care.